Okay, so this multiplication rule, and I have seen the test, so I know what's coming throughout the whole chapter. And we're going to have two rules. We're going to have a multiplication rule and we're going to have an addition rule. Multiplication rule goes with the and. Okay, so multiplication rule is going to be when we're doing two things. This and this are happening. And again, finding the probability of A and B happening is not the same thing as conditional probability. So conditional probability was the first thing that we're learning today. This probability of A and B is the second thing that we're learning today. Okay, so when you want to find the probability of two things happening, it's going to depend on whether or not they are independent or dependent events on what we do. We're going to multiply both cases, but what we multiply changes based on whether or not they're independent or dependent events. So the very first thing you have to do anytime you're finding the probability of two things happening, and the word is and, because we're going to do or next time, the first thing you have to do is determine whether or not they're independent or dependent. So two cards are selected. Now, again, this is not the same kind of situation as it was the first time, because we are selecting two cards. But notice the difference in the question. It says find the probability of selecting a king and then selecting a queen. There's the word and. Let me go back up to the first one. That was not what we did the first time. It says two cards selected. Find the probability of just the second card being a queen, given that the first card was a king. Nowhere in there does it say king and queen. They're not asking for the probability of that first card. They just told us that it happened. We were only finding the probability of the second card. This one over here, we're finding the probability of both cards. The probability of the first one was a king, and then the second one was a king. That's a different problem. Students miss that sometimes. So they didn't name our events. So I'm going to use K for king and Q for queen. So the probability of king and queen. We've already labeled that that these two things are dependent. So since these things are dependent, and we know that they're dependent because once we draw that first card out and we do not replace it, this changes the sample space. All right, so since it changes the sample space, it is affecting the probability of this one happening. So when they're dependent, this is what you have to, this is the rule that you're going to multiply by. You're not just going to take the probability of finding a king and multiply it times the probability of finding a queen. That's what you do if they're independent. What we're going to have to do here is find the probability of getting a king and multiplying that times the probability of getting a queen, given that the king has already been drawn. So we know what the probability of finding a king is because there are how many kings? 4 out of a total of 52 cards. And then we already found this. This was the first problem that we worked. But even if we hadn't, here's how you would do it. You would say, okay, how many queens are there? There's 4 in a deck of cards. We've already drawn a king out and we did not replace it. So we no longer have a sample space of 52. We only have a sample space of 51. And now you just multiply those two together and reduce if you can. Use a calculator to multiply those two together. And when you use a calculator, you get 4. It's going to reduce it for you. 4 over 663. And that's going to reduce down to 0.006, which is going to be about 6%. All right, I'm going to stop it right here because my dogs are doing something they're not supposed to do.